my name is Dana Golden. We're continuing along with our PowerPoint review of Python with an introduction to Numpy. So what is Numpy? Numpy allows you to work with matrices and large data sets in Python. It dramatically speeds up Python operations. Basically, the idea is vectorization, because when you utilize a for loop, that's very slow, but when you add a matrix, that's a lot faster. Computers really think in terms of matrices. Numpy is effectively MATLAB and Python, so there's a lot you can do with Numpy in terms of matrices, in terms of the manipulation of different data sets. It's extremely valuable for econometrics and machine learning if that's something you want to do in Python. So arrays are the unit of observation in Python. In Numpy, by creating arrays, we can perform Numpy operations. To create arrays, you can use np.zeros, which creates a matrix of specified size of just zeros. You can also use np.ones, which creates a matrix of specified size of just ones. You can use np.linspace. It returns evenly spaced numbers over an interval. You can use np.arrange, which is the same as linspace, but uses a step size. So np.linspace uses the number of numbers you want to return over the interval, whereas np.arrange, you give a first number and a last number, and then you give the size of the step between the numbers. np.I creates an identity matrix of set size. np.random.random creates a random matrix. If you want to get the shape of an array, you do array.shape, and that gets dimensions as a tuple. If you want to get the length of the array, you just do len of array. So some array mathematics, let's say we have array, np.array of A equals 1, 2, 3, and we have array B, then G equals A minus B. So notice that array B is made up of 2 rows, each with 3 columns, and array A is made up of 3 rows with 1 column. So 1 minus 1.5, 2 minus 2, 3 minus 3, and then 1 minus 4, 2 minus 5, 3 minus 6. So you can think of this as kind of like vector addition to a matrix, and then you can also add the vector to the matrix, which adds each of the rows to the you add the row to each of the rows of the matrix. You can also divide. You can also multiply. So these are all things you can do with a vector and array. You can also do other matrix math. You can also do matrix multiplication. You can also do dot products, np.dot. So other matrix math, you can do np.exponential, finds the power of E of every matrix element. np.log is the natural log of each element of the array. np.square root gets the square root, and then np.sign dot gets the dot product. You can also do basic matrix operations, at, which multiplies 2 matrices, times, which element-wise multiplies 2 matrices, dot t, which takes the transpose, and then you can do different linear algebra operations, including linalg.ig, which computes the eigenvalues and eigenvectors, linalg.inverse, which computes the inverse of the matrix, and linalg.norm, which computes the norm of vector or matrix. Boolean masking is a technique that's very important in Python and often used in machine learning, and basically allows you to pull from an array based on conditions. So you have a source array and you have a bool array, usually created by some condition based on either the source array or another array, and then when you apply this bool array to this destination array, you can get basically you fill in you fill in the destination array where you fill in with the source array where this bool mask is true, and you fill in with the destination array this is false. This is a very useful technique in matrices. So formula for linear regression is beta equals the matrix of betas equals x prime x to negative 1 x prime y. And you can do this through np.lineage.inverse x dot transpose at x dot transpose at y. And you can also do np.lineage.least square xy. So that's NumPy, and I hope you have a great day. Thank you.